There we go. I did my thesis research on the effects of prescribed burning on mainly soil water infiltration rates, but other select physical and chemical soil properties in East Texas. So I kind of broke down my PowerPoint to be a little bit smaller so I can move through it a little bit quicker and kind of highlight the points that y'all are more interested in from my conversation with Jenny. So the main reason that this study came about was that there were numerous studies outside of the southeastern United States and mountainous regions and coastal regions, but there were very few studies on prescribed burns or even like wildfire burns that were conducted in the Southeast forests. There weren't any that were conducted in Texas. And none of these studies that I found had pre-burn data associated with them. So, but if they did have pre-burn data associated, it was after a wildfire, they went out and sampled an unburned site of similar characteristics. So it wasn't a true pre-burn sample on the same exact site. But this study has true pre-burn data on the same site that a prescribed burn went through. The objectives of my study was to determine the influences of prescribed burns on soil infiltration rates and other soil physical and chemical properties, as well as what effect does prescribed burning have on the soil water infiltration rates. So just a little bit of my methodology. I took pre-burn samples before the fire. I did a 1 month post-burn sample after the prescribed fire went through, and then I did a 3 month post-burn, which I call green up sample, 3 months after the prescribed burn went through. I worked during the 2020 and the 2021 burn seasons, and I had plots established on the United States Forest Service on the Davy Crockett and the Angelina National Forests. And then I also had several plots on the Sam Winston's Winston 8 cattle tree farm. This is a little figure of how my plots were established, just so you have an idea of where they were established. So a lot of the plot centers on the national forests were pre-established based on their, they were already gathering data in these areas. So I just piggybacked on the back of their data or on the back of their plot establishments. And from the plot center, I would take a random number generator and choose a direction and a distance. And that would be my subplot 1 or my first sampling location. And then for my second sampling location, I would do the same thing and base it off of where I was standing for subplot 1. In the field, I used a double ring infiltrometer method, which was sunk 5 centimeters into the soil profile. And then I filled it up with water and took measurements at set time intervals. And the intervals were determined on how fast the water was actually infiltrating into the soil surface. But in the end, it all was converted to centimeters per 1 minute. So however many centimeters it was infiltrating within a minute. Statistically, I used a 2-factor design, which was the interaction of the time and the site. And I used a t-test. And for my t-tests, I tested pre-burn to post-burn timeframes, post-burn to green up timeframes, and then the pre-burn to the green up timeframes. And then I used a one-way ANOVA and determined the interactions between the 2 different burn regimes, because the National Forest is on a 3-year burn regime-ish. And then the Winston 8, the privately owned, he's burning every year and sometimes twice a year in the areas that I was sampling in. And then my p-value or my was 0.1. So these are actually the soil infiltration, the water infiltration rates that I collected for each plot. So, and then at the edge, you can see in bold that I averaged the rate just for easier digestion of all the numbers because I know that there's a lot. But I don't know if y'all can see there. Can y'all see my mouse on there?
Yes.
Okay, so the way that this table is read is it's the t-test comparison. So it's comparing the pre-burn to the post-burn, the post-burn to the green up, and the green up, or in the pre-burn to the green up. So the mean average of infiltration, you can see in pre-burn was 1.90 centimeters per minute. And then it increased at the post-burn to 2.63 centimeters per minute. And then it increased again at the green up and it averaged 2.92 centimeters per minute. So what it means is that it significantly increased from pre-burn to post-burn timeframes. And then it also significantly increased, the change in mean significantly increased from the pre-burn to green up timeframe. So over the 3-month period, we saw a significant increase in soil water infiltration. These are some of the other physical soil properties that I collected. I'm not sure how interested y'all are in those, but I know y'all were definitely interested in the infiltration. And then this was the comparison between the National Forest burn regime versus the Winston 8 burn regime. And over here, you can see that the green up pre-value, that there was a significant difference during the green up time frame, that soil infiltration had increased significantly between the two different ones, that there was a significant difference between the burn regimes there. But within the other two time intervals, that the burn regimes were on par with each other for soil infiltration, as in they weren't significantly different. I know that y'all were interested in the total carbon percentage, so I put this in there. It actually decreased the carbon, but not by a significant amount. So there was no significant change in the amount of carbon that was released or the amount of carbon that actually stayed in the soil. It remained unchanged. That's the same for there are just slight differences or significant differences between the two different burn regimes on burning the National Forest versus burning on the Winston 8 and the total carbon percentage that was retained. This study was cited with I cited a bunch of other studies who described increases in soil water infiltration rates, contradicted a bunch of studies who found that their infiltration rates decreased after a disturbance or intense fire, contradicts studies who showed an increase at first and then a slow decrease over time. And then it also contradicts other studies that didn't find any difference in soil water infiltration rates. The conclusions of this, the prescribed burning did positively impact soil water infiltration rates on these East Texas soils. It could be a short-term response. There's no long-term data on this, so there's no way to actually say that 50 years from now, if you're still on the same burn regime, it's still gonna be increasing. But over the short 3-month time frame that I did do samples, it increased 53.68% from the pre-burn to the green up time frame, which I found was very interesting. Of course, I'd like to acknowledge my committee members, my field and lab help, the U.S. Forest Service, and then Paul Wood with Sam Winston's Winston 8 Land Farm. Do you have any questions?
Hey, Cassady. Sorry. Can you hear me?
Yeah.
Okay, I had a question. Thanks for coming to present. I also can introduce myself. I'm Lauren from Texan by Nature. working with Texas Longleaf through the Conservation Wrangler program. I was curious, like, what your conclusions are about how the prescribed burn possibly impacted the water quality. I saw you had some data on different nutrients within the soil. I was wondering if you made any like conclusions on that, or if it's still, you're still looking at it.
I'm still looking at some of it, and some of it is coming out in publications. This is what they were letting me share at other conferences, so I didn't want to stray too far from that with it being under embargo still. But I did not look at soil or water quality. I was only looking at water infiltration into the soil.
Okay, awesome. Thank you.
Mhm.